All right, let's talk about some more multiplying polynomials. So we're going to multiply the following. First example I have here is in parentheses, I have x minus 4 squared. Now this type of problem is very, very, very common that students make a mistake on it because they see that square on the outside and they start thinking, oh, let's just distribute it in. You cannot do that. You can't do that because of the addition and subtraction between the x and the 4 is what prevents that. You cannot distribute it. So what you got to think about is just think about how exponents work. So for example, if you have x squared, something to the power of 2, that just means take x times x, whatever it is times itself. So if you have some parentheses squared, it's that parentheses times itself 2 times. So if I have x minus 4 squared, what I like to do is I will write this out 2 times just to see what we're doing. So I'm going to have x minus 4 times x minus 4. Now it becomes a little bit easier to see kind of what's going on. So now we just need to do the distribution, combine like terms, clean this all up. So I'm going to have x times x, which is x squared. X times negative 4 is negative 4x. Then I'm going to take my negative 4 and distribute it all the way through. Negative 4 times x is negative 4x. Negative 4 times negative 4 is 16. Only thing left to do is combine like terms there. So start with the x squared. I have an x squared term here that combines with nothing. I have a negative 4x and negative 4x, which is negative 8x. And then I'm left with a plus 16 on end. So I have my answer there in standard form. All right, one more example I want to show you. So I have 2x plus 3 times 2x minus 3. So looking at this problem, very, very similar pieces we're multiplying there. 2x plus 3 and 2x minus 3. So the difference is a plus and a minus, plus and a minus. So something really interesting is going to happen here. We'll see it as we get through the problem. So you're going to continue through with your distribution as always. Take 2x times 2x. So if you do 2 times 2, that's 4. X times x is x squared. So when you do 2x times 2x, that's 4x squared. We take 2x times negative 3, which is negative 6x. And then take our plus 3 and distribute it through. So 3 times 2x is positive 6x. Sorry about the announcement. So 3 times 2x is 6x. And then 3 times negative 3 is negative 9. So all I have to do then is combine like terms, start with the highest power, work our way down. So I have a 4x squared to start with. So we have 4x squared, a negative 6x, and a positive 6x. So a negative 6x plus a positive 6x, that is 0x. So that is not something we're going to include. But we do end up with that minus 9 there, bring that down. So I have 4x squared minus 9. That is my answer. So the interesting thing that I was talking about on this one is whenever you have the same, but one's plus and one's minus, what happens is that middle two terms, those are going to go to zeros. Those are going to disappear. All right, one last example, kind of a little application problem here. Use a few other things. We're going to find the area of the following rectangle. So things you need to be thinking about is, first off, what in the world is an area? And the area is just the base times the height. So the bottom times the side. You don't want to mix this up with perimeter. Perimeter is just taking all the sides and adding all the way around. So adding all the way around will get you the perimeter. So we just want the area, which is base times height. So I need to take my base would be 3x minus 8 times the height, which is x plus 6. And we're going to multiply those together. So 3x times x is 3x squared. 3x times 6 is 18x. And then we're going to distribute that negative 8. Negative 8 times x is negative 8x. Negative 8 times 6 is negative 48. So when you combine like terms there, start with the highest power, which is 3x squared. And then go 18x minus 8x, which is 10x. and you end with minus 48. So that would be the area of the rectangle. And that is multiplying polynomials 2.